So I'm Brian Beal from the University of Maine Machias, as well as, let's see, how are we advancing here? Okay. I'm also the Director of Research at the Downeast Institute, and I just wanted to make sure that everyone understands what the Downeast Institute is all about. There seems to be some confusion, so I thought I would start by just talking about the mission and the vision of DEI. So DEI's mission is to improve the quality of life of the people of down east and coastal Maine through marine research, through marine science education, and innovations in wild and cultured fisheries. Folks think that we just work on cultured clams, but we're obviously very interested in wild clams as well. And our vision is that our groundbreaking work will generate new knowledge in the marine ecosystem for all who depend upon it. So, what I am going to be talking about today is a study that we conducted in 4 Maine communities this past year from May to November, looking at the effects of brushing as well as netting on the recruitment of soft-shell clams. We start in a climate of change, and I don't necessarily mean climate change, but this is a climate of change. If you look at the landings for the state of Maine for soft-shell clams, since 1950, you'll see a major skid in the 1950s and a major bump coming up in the late 1960s and early 70s. And then from the period between 1970 and 1980 to the period between 2008 and 2018, a 60% loss. That kind of is on par with what was lost between 1950 and 1960. There is a reason, and a lot of it has to do with temperature that drives marine ecosystems. So focus your attention on 1950s and take a look at the average wintertime temperature measured at Booth Bay Harbor. Every one of the dots represents an average between the 1st of January and the 31st of March on an incredibly important data set that's been kept since 1903. Every day, the seawater temperature has been recorded at West Booth Bay Harbor. And I've taken it from 1945 to 2018. This is a data set that anybody can get from going on the DMR website and looking for their environmental data. But look at how warm the water temperatures were in the wintertime in the 1950s, early in the 1950s. And then follow, hello, and then follow, a hard time. There we go. The triangles represent the average for that particular decade. So if you look at the average from 1980s all the way to the average of the 2000s and 2010s, you see a trend, and that trend is increasing water temperature. And so everything that we do, whether we're talking about pollution or whether we're talking about quahog growth or clam recruitment, it has a lot to do with temperature driving the system. So if we simply go back to that, if I can do this, no, I'm not going to be able to, but if we remember the landings from the 1950s, they plummeted. This works too.
I should.
Oh, beautiful. It's always good to know. If you look at the landings in the 1950s, they plummeted, and it wasn't because there weren't any clammers, it was because there weren't any clams. And that is associated with this increase in water temperature that you see here in the 1950s. And I'm sure most of you know that accompanying that water temperature in the 1950s was an explosion of green crabs. And that was what ultimately resulted in the lack of clams in those years. So anyway, temperature, on top of what folks are trying to do to increase clam landings in their towns. And one of the aspects, one of the management techniques that's available to communities is to brush. And this is a technique that's, I would call it more ancient than present, but a lot of towns continue to do it. And I became interested in assessing the efficacy of brushing because I had looked around and not seen a lot of work that had been done quantitatively on this. So before I get into brushing, I really need to talk about the life cycle of the soft-shell clam. I think this is probably my 5th or 6th year in a row where I have talked about the life cycle of the soft-shell clam. So I will do it fairly quickly, but clams, like oysters and quahogs, spawn, and they are separate sexes. They shoot their sperm or release their sperm and eggs into the water column where fertilization occurs. Soon thereafter, you have a very, very tiny animal that has a gut and a mouth and a heart and gills and then cilia that allow it to swim through the water column. That's the trochophore. It doesn't have a shell. It develops a shell in the veliger stage, and that's the top one that you see there. And then they continue to develop and grow to a stage called the pedi, meaning foot, pedi veliger. So they can swim and they can probe sediments at the same time. So they'll put their velum in and sink to the bottom, stick out the foot, and probe the sediments. And if the sediments are penetrable, then they will land there and undergo a fairly rapid metamorphosis, where they turn from more of a quahog shape into an elliptical shape of the juvenile clam. And this cycle takes between 2 to 4 weeks, depending upon seawater temperatures. So this is an egg that was just fertilized. It's 2/1000ths of an inch. This is a slide of a 10-day-old Maya larvae, thanks to Kyle Pepperman, who took this photo with his iPhone. We now have microscopes at DEI that can do this, so we don't need the iPhone anymore. But so this is an early veliger. And then this develops into a, let's see if I can do this. I think that's moving. And so this is a later veliger, and it's going to do its thing here in a moment by sticking out its velum. It has a developing foot, and it's going to fly off of our screen in just a moment. So this is a later veliger. And then these are the recently metamorphosed soft-shell clams that are looking for sediment to burrow into. And these clams are, as I say, they're about 1/4 of a millimeter, or 1/125th of an inch. And this is the size at which the brushing study is all about, is this size clam. So there was an article, a paper, and probably John Kreuter would appreciate this more than anybody else in the room, but Melbourne Carricker was a marine ecologist, and he worked at 3 universities, Rutgers, University of Delaware, and University of North Carolina, Chapel Hill, which is where he was in 1961, but the study that he was doing was looking at hard clams, Mercenaria, in New Jersey. And in the paper that he wrote, which was published in a very interesting journal called the Journal of the Elijah Mitchell Society, that's the University of North Carolina's journal, quote, "Objects in the water, acting as baffles to currents, create velocities and turbulence which may stimulate these petty veligers to set around the baffles in greater abundance than on bottoms without baffles." And I think this is what he was saying, is that water is moving across these flats at high tide, and if it encounters something that will interfere with the flow, then it will create these eddies. And the eddies are slower moving water, and it is this difference between the fast and the slow that allows clams that are very, very tiny, smaller than grains of sand, that are getting pushed on top of the mud flats around as these currents come over them. So if there's baffles or something that will slow the water down, then that may be in a place where these small, tiny clams can become enhanced, which is the anticipated reason for brushing. And so, again, what we're hoping is that these clams will settle in the brushed areas, or soon in areas away from the baffles, but fairly close, so that the enhanced area is what we're interested in. So when I took a look at communities that had been doing brushing and tried to find out how it was going, and some communities said it works really well, and some communities said, well, we're never going to do this again. And when I asked, how it was that folks were assessing whether or not they were successful, it was because we found clams in the brushed area. And so I asked the question, well, did you sample in any other areas that I would call control areas to see whether or not there were clams that had settled there? And for the most part, the answer was no, we didn't sample anywhere else. So from a scientific point of view, without proper controls, it's very hard to tell whether or not baffles or brushing or any other treatment is effective in enhancing these clams. When you go on the DMR website and look at the management activities that towns have essentially access to, one of them is to enhance spat fall through brushing. And when these towns do their annual shellfish management review, one of the boxes that can be checked off is enhancement of natural seed due to brushing. But unfortunately, what I found was a single study by Chris Peterson and his student who did a senior thesis project through the College of the Atlantic. Was the only quantitative data that I could find on the effectiveness of brushing compared to control plots. It was a fairly small scale study, right, Chris?
Yep.
Okay, done at one site. And that study showed that brushing was ineffective in enhancing wild clam spat. So using that information, we decided to set up what's called a comparative experiment, which is just the same experiment set up at 2 or more different places. And we wanted to have a Downeast town, a mid-coast town, and a southern Maine town. And we were fortunate to get funding through the Broadreach Fund, as well as Maine Sea Grant, to pull this off for 2019. 3 communities. One was in Gouldsboro, the other one was in Bremen, and the other one was in Harpswell. And what we did was to cut spruce boughs, and the same spruce trees were used for all of the sites. They came from Great Wass Island. We arranged the spruce boughs that were 26 inches tall into a 7-row by, I'm sorry, 1, 2, 3, 4, 5. Anyway, rows by columns. We've got 7 rows of spruces. And this is what the setup would look like in, I think this is Gouldsboro at Bunker Cove, and this is at Spruce Cove in Harpswell. And what we did then was we organized a central 22-foot by 14-foot plot that was brushed. And then we set up 8 control plots surrounding that central brush plot. And then we also had 1 control plot that was, excuse me, about 100 feet away, that's labeled here as Control 9. And so what we did was we compared ultimately the average number of clams recruits in the brush plot to the average number of clam recruits in the 8 control plots. And so if brushing is effective in enhancing small clams, then there should be more clams on average in that brush plot than in the control plots. However, it's likely that recruits could get pushed or moved by tides or wind or currents into the control plots surrounding them. So if there was enhancement in 2 or 3 of the control plots, we ought to be able to see that as well. And then lastly, we used that 9th control approximately 100 feet away from the 9 plots and compared the average number of recruits there to the average of the 9 plots. So we had multiple ways to tell whether or not brushing was effective. In addition, we used nets, like Kyle described, although his nets were 12 by 12, these were 14 by 22 foot plots, just the same size as the brush plots. We applied some styrofoam floats to these to kind of baffle the currents, as well as keep the netting off of the flats and from interfering with the feeding of any clams that might be there. This was a picture taken in Harpswell on that deployment date. And so we had plots that were 150 feet away from the brushing plots that contained these netted plots with their controls. And so the question that we're asking is twofold. One, does brushing work? Or two, does netting work? Now, colleagues of mine at the DMR and I just put out a study from 2014 to 2015 in Jonesboro, in St. George River, and also in Booth Bay. And what we found was just putting the nets out indiscriminately, not paying any attention to anything, to see whether or not putting a net out and having an enhancement of wild clams would work. It worked 8% of the time. So, the other problem with assessing recruitment due to brushing or netting is that predation is occurring. And so when these clams hit the mud, they may be susceptible to attack by anything from small fish to green crabs and other predators. And we've shown since the 1990s, actually, that predation is a pretty important regulating mechanism for these small soft-shell clams. And the latest work that we've been doing in the southern part of the state has shown that predation is very, very intense. There's a loss in some places of over 99%. So it's possible that then recruitment in the brush plots is being masked by predation. And to get an idea about that, we set out recruitment boxes on the flats in each one of those brushed plots as well as the control plots. The boxes had a fine mesh called pet screening. It's 1.7 millimeters by 0.9, so it's a very, very tiny mesh. And it takes care of the large predators. But green crabs still can recruit into these boxes, so they're not perfect, but they're as close to what we've always looked at recruitment as kind of a black box, and these small, tiny, silly recruitment boxes have given us a window that we didn't have before. And I want to make sure that everyone understands that the boxes are simply passive collectors. They're not magnets. And this is what the boxes look like. And this is an artist's rendering of what is going on in the box. I don't know if you can see that. That came up pretty well, and I'll tip my cap to Sarah Randall for designing this. And this will be a poster later on today. But what it shows is that clams fall out of the water column and they land on the mud. And some of them make it, and some of them get eaten, and some of them make it into a box. And if they make it into a box, then they have a much better chance of being found later on. So when we find the boxes later on, we find that they're full of mud, sometimes. We scoop the mud out, and we place the mud into sieves, in this case 1 millimeter sieves, and wash the sediments away and expose what's in the box. Here's a box that came from Thomaston that we put out in June of 2018 and collected in December of 2018. And after we washed all the mud out of the box, this is the clams that we found. And we counted them individually. We found almost 1,900 clams in this one box. We had 15. The clams ranged in size from about 1/8 of an inch, 3 millimeters, to a little bit less than an inch, 22 millimeters. And we took a small sample to get a size frequency distribution. So the boxes. So if you were to look down on every one of the 3 sites in Gouldsboro and Bremen and in Harpswell, you'd see this array. There's what I call blocks, 3 blocks, and in each block we have a netted group and a brushed group. And these were about 150 feet apart. The little black triangles, the little black rectangles that are inside the larger rectangles are the recruitment boxes. So if you do the math, there's 54 control plots, or 54 plots total, and there are 54 recruitment boxes. So here's our site in Gouldsboro at Bunker Cove. We took samples of the flats and the mud before we started, and Gouldsboro had about 7 clams per square foot. Our Broad Cove site in Bremen had about 2 clams per square foot, and our site at Spruce Cove in Harpswell had about 1 clam per square foot. So the recruitment boxes then give us some measure of whether or not there were any clams that settled to the flats. We may not find any clams, but we could at least say that clams were present in the water column. So here are the results of the recruitment boxes. So did clams settle in Gouldsboro? Well, yes, they did. In fact, we found the most clams of all 3 sites at our Gouldsboro site. Now, each one of the bars, and I know this is a little bit tricky, but the bar doesn't represent a recruitment box that's in a brush, just the brush plot. So the green on the left would be the brushed, so there was a recruitment box in the brush plot, and then in the 8 surrounding control plots. And that first green bar represents the recruitment boxes that were in that area. So each bar represents 9 boxes. And you can see that there were about 3 times more clams in the recruitment boxes associated with the brushed plots than the netted plots. And that was statistically significant. Take a look at the y-axis, the vertical axis. It ranges from 0 to 1,000. In some of the boxes we found 1,200 clams. In other boxes we found about 50. But in Bremen we didn't find many clams at all in comparison. And it turned out that, yes, we did find on average more in the brushed plots, 4.6 versus 1.3, but you can see that the driver there was just simply a single block that for whatever reason there were more clams that settled there. It's still statistically significant, but I don't put much faith in that particular assessment. In Harpswell, we found 2 species of bivalves that settled into the recruitment boxes. And for softshell clams, we found 1.85 on average per square foot. Not a lot, but at least we know that clams settled. And there wasn't any difference between the brushed and the netted plots in terms of the numbers. We also found hard clams, and we actually found 1.3 times more hard clams per box than we did softshell clams, about 2.45 per square foot. But again, no significant difference in terms of whether or not we got more in the brush or the netted plot. So in November, at the same time that we collected the recruitment boxes, we took 3 core samples, and our core samples are a number 10 can. They're 6 inches in diameter and about 8 inches deep. And we took 3 of these core samples from each of the central plots, either the brushed or the net, as well as the control plots. So if you do the math, we took 180 cores off of the flats, and each core weighs about 10 pounds. And that's why we needed an army of people to help us get almost 2,000 pounds of mud off of these flats for each one of the studies. Here are the results. Gouldsboro. We didn't find a single clam in any of our samples in any of the brush plots. We found some clams around the control plots, but there wasn't any differences in the averages. When you look at the numbers that I have in these, and I'm not going to spend a lot of time on that, but the first number is the average per square foot. So if you look at the upper left-hand box, it's labeled Control 8. It says 0.6 plus or minus 1.3. The 0.6 represents the average number of clams in Control Plot 8. The 1.3 is a measure of how variable that is. And if that number that's variable, the variance, in this case it's actually a 95% confidence interval for those of you that are interested. If that number is greater than the mean, then it's likely that it's highly, highly variable. And that's what we found, essentially. But of the thousands of clams that settled to the flats in Gouldsboro, we got 2.4 clams per square foot on average at the end. Some of those boxes had 1,200 clams in them. And so there was a very, very intense predation going on, or loss. In other words, we found no discernible enhancement effect due to the brushing. We found very similar results in Bremen, where we found fewer clams, but again, no discernible effect due to brushing. Someone want to get that? And then in Harpswell, we found for the first time clams in the brush plots, but at such a very low density that it wasn't different than zeros, essentially. And so in Harpswell, for soft-shell clams, we found no discernible enhancement effect due to brushing. For quahogs, we actually found no significant difference among the plots, but no discernible effect due to brushing on the quahogs. So what about the results from the indiscriminate use of netting? Well, in Gouldsboro, we lost 2 nets. And when we went back, we didn't know how long the nets had been gone for, so we just simply asked, did the missing nets have any long-lasting effect? And the answer was no. We didn't find any more clams or any fewer clams in the controls versus what was netted. But if we looked at the third block and the only one where the net was intact, we found 85 clams per square foot with a lot of variability in the netted plot versus the control plot. But at the same time, in the same block, the brush plot had no clams and the control plot had about 5 clams. So in Bremen with the nets, we didn't find any difference among the plots. There was no discernible enhancement effect due to the netting. And in Harpswell, for soft-shell clams, it was the same thing. No discernible effect due to netting. With hard clams under nets, we actually found 5 times more quahogs under netted plots than we did in the controls. So we found some effect due to netting, but again, it's not consistent. So the data, what do the data suggest? Well, I think 3 things. First, that objects like brush do create some resistance to tide and wind-driven currents. They probably enable clams to settle onto the flats and remain either in the plot or in a halo. But brushing may have worked when seawater temperatures were colder. Unfortunately, now seawater temperatures are increasing along with the number of predators. And so these objects, this brush or anything that baffles, tends to provide a habitat for predators, like crabs and bottom-feeding fishes. So rather than using brush to enhance juvenile clam density, netting will probably yield better results if sufficient numbers of clams settle into the flat, and that's where Kyle's advice comes in, which is that you can use sentinels the year before to give you an idea of whether or not the flat is a good recruiting flat. And if you don't want to do that, you can do it in multiple years to get a better data set. But there is a way to have netting help you. I wanted to make sure that everyone understands that what we found here wasn't unique. So I did some digging. I did a Google Scholar search for settling clams and infrastructure or habitat, and found this paper that was published in the journal called Estuarine, Coastal and Shelf Science in 2014. That was done in Portugal as well as in England. And the Portugal results were pretty interesting. They sampled mudflats and intertidal areas, some of which were vegetated and some of which weren't. And they were looking for green crabs. And they found approximately twice as many green crabs in vegetated versus unvegetated. And guess what the vegetation was? Eelgrass. It wasn't Zostra marina, it was a species called Zostra noltii. But the point is that green crabs are looking for an escape from their predators. Everything eats green crabs. So they have to act in such a way so that they escape their predators. And what the graph here shows is that if there's an object that sticks up into the water column or whatever, like eelgrass, green crabs are attracted to that. And it's not just one, it's one size of green crab, I should say, and it's juveniles. So these juvenile crabs are attracted to these areas that will allow them to forage, feed, as well as get protection. Real quickly, I'll end with the study that was done in Millbridge from the 4th of May to the 26th of October last year. It was a study, this one was done, I'm only going to talk about the results of one study because the results of the other were very similar. The brushing study here that I've circled is in Pigeon Hill Bay, and there were 8 treatments. So there were plots that were brushed and those that weren't. Of the brush plots, some were netted and some weren't. And of the not brushed plots, some were netted and some weren't. And then plots were either seeded or not seeded. So if you do the math, you get 1, 2, 7, and 8 treatments. And each one of these treatments was a 12-foot by 12-foot plot. It was seeded with 2,500 clams from the hatchery, and each treatment was replicated 4 times. And so the brush was placed around the plots, which was what the folks from Millbridge wanted to do, which is a very cool idea. The results were a little less cool. There wasn't an enhancement effect due to brushing, and a lot of it had to do with some of the nets. Most of the nets, according to Kyle, became loose during the trial. They didn't fly away, but if there's any kind of area where the edge of the net isn't secure, what gets underneath of it? Well, you can see here that on the left-hand side, there was actually a few more clams in the netted plots, regardless of whether they were seeded and regardless whether they were brushed, compared to the non-netted plots. Most of the clams in the plots that had been seeded were found dead and crushed by green crabs. The brushing, again, didn't have the desired effect. Netting did have a desired effect, but the effect was different depending on whether or not the plots were seeded. So to summarize, and this is the last slide, field studies that we conducted last summer demonstrated the same result, which was that brush can slow down currents, and it may create an excellent environment for clams to settle and stay, but it cannot protect small clams from being attacked by predators. And therefore, alternative measures should be used to enhance wild clams on flats. Brushing may have produced the desired effects, which was increasing wild clam densities when seawater temperatures were cooler than they are now, but the threat from predation wasn't as severe as it is then. It wasn't as severe then as it is now. Predation's pretty intense. So I want to thank all of these people from Gouldsboro, Bremen, and Harpswell. I didn't list the ones from Millbridge because I didn't get that list, but I want to thank those that helped from Millbridge as well, along with DEI staff that did a lot of the sieving and helped me with the data analysis. And again, thanks to Maine Sea Grant and the Broad Reach Fund. Thank you very much.